Hello, fifth graders. I hope you're all doing well. My name is Mr. Tang, and I'm going to be talking through your BCPS-TV lesson of the week, and that's going to be combined volume of prisms. In your packet, this is going to be week 5, lesson 1, for the week of April 14th through 17th. All right, let's start with our objective. Today we are going to use the volume formula in order to determine the volume of a solid figure that is a combination of two or more rectangular prisms. Okay, so there's a lot to break down here. As you can see, the main part of this is going to be the discussion around volume. We're going to be using a formula for it. We're going to be using that to help determine the volume of different figures that are made up of two or more smaller rectangular prisms. All right. So let's go ahead and take a look at one right away. This rectangular prism is made up of two or more rectangular prisms, actually. But we just have to figure out how we can separate or partition it. In order to do that, we need to think about the different prisms that make up this shape. So as you're looking at this right now, I want you to think about using imaginary lines or breaking it apart in your head. If you can come up with a way to separate that into different rectangular prisms. We'll come back to this one.
A building supervisor wants to find the volume of a storage building to determine how much storage space is available. How can you find the volume of the building? You can find the volume of the building by using the formula for a rectangular prism. First, separate the building into two rectangular prisms. Then, find the volume of each rectangular prism and add the two volumes together. What is the formula for finding the volume of a rectangular prism?
Select your answer.
So it's nice that they went ahead and separated the two prisms for us. But if they didn't, you would have to be able to see where one starts and where one ends. It's a lot easier if we were able to have these in our hands, but since it's on a piece of paper, we can't really move it around a lot. It's a little bit more difficult to be able to see that. When we talk about volume, we could think about what we did with area and how we took the length and the width. Did we, if you think about it, did we add them together to find the area, or did we multiply them? That's right, we multiplied them. So very similar to area, volume is going to be taking a look at the relationship between the length, the width, and our new dimension, the height. So we have two of them here. In A and B, we have a length, a width, and a height. So again, are we adding them together or are we multiplying them? We're going to be multiplying them.
The formula for finding the volume of a rectangular prism is volume equals length times width times height. Find the measurements for length, width, and height of each prism to set up your equations.
So for A, we have 9, 4, and 5. For B, we have 10, 9, and 7. But take a look at this 6 right here on top of B. That is the difference between the space on top of B and then the leftover prism of A. So it's going to get a little tricky as far as knowing how to read our dimensions and seeing where one thing begins and where one thing ends. The reason we use 10 for the side here instead of 6 is because 6 stops halfway through and doesn't go all the way. So with that being said, let's go ahead and take a look at our different volumes.
The length of prism A is 4 meters. The width is 9 meters, and the height is 5 meters. Let's figure out its volume.
Go ahead and take a second to go ahead and multiply that together. You have 9, 4, and 5. What are some strategies are you using? Take 2 of them first and multiply them, and then multiply that answer with the last number. I see one multiplication factor I would love to do first.
Volume equals length times width times height. 4 times 9 times 5 equals 180. The volume of prism A is 180 cubic meters.
The way I solved this was I took 4 and 5 and I multiplied those together first because that's an easy basic fact for me, and that's 20. So then if I have 20, I can take 20 and multiply that by 9. And I know that 20 is 2 times 10. So then I have 9. So then I can read that as 9 times 2 times 10. 9 times 2 is 18. 18 times 10 is 180.
The length of prism B is 10 meters, the width is 9 meters, and the height is 7 meters. Let's figure out its volume.
So take a second and go ahead and multiply 10 times 9 times 7. Again, I see a basic fact that I'd love to do. Maybe instead of doing it first, I'll do that last. I want to save it for last.
Ten times 9 times 7 equals 630. The volume of prism B is 630 cubic meters.
Again, in figuring out that multiplication, I would have multiplied 9 times 7 first and got 63, and all I would have left is 10 times 63. And if I'm annexing a 0 to 63, I'm multiplying it by 10, then I would have 63 tens, or 630.
Add to find the total volume of the storage building. 180 cubic meters plus 630 cubic meters equals 810 cubic meters. The building has 810 cubic meters of storage space.
Wow, was that video fun or what? Okay, so in review, when we're working with volume, we have our basic formula for volume, which is volume equals length times width times height, or volume equals base times height. And your base is simply your length and your width. So we have our length and our width multiplied by our height. When we're taking a look at combined rectangular prisms, we're taking a look at a rectangular prism that's created by combining more than one rectangular prism. So then in doing so, what we have to be able to do is identify what rectangular prisms this combined one is made of. So I'm going to go back and use the example that we started the day with. And we took a look at this as, what I'm going to do is I'm going to break it up 2 different ways for you. So we can take a look at it like this, where we have the top and the bottom. And we'll call this one rectangular prism A, and we'll call this one rectangular prism B. It doesn't matter as long as they're labeled. It could very well just be the other way around also. Just make sure you have your prisms labeled. So I can do A and B. Again, just make sure you're labeling your pieces. Okay, and then on the other one, on the right here, what I'm going to do, instead of going top and bottom, we're going to go front and back. So I'm cutting an imaginary line here. And I want you to try to imagine if you had this in front of you, if you had this like as in like Legos or something, you can break it apart, right? So on the left, we have A at the bottom, B at the top. On the right here, we're going to have A in the front and B on the back. So it's like taking the front piece off of that. So the important thing is that when you do figure out how you're going to partition or separate your prisms, we have to be able to figure out and identify what your length, your width, and your height are for your individual prisms that we broke down. Let's go into depth a little bit more with this example. So I have A at the bottom, B at the top. So there's a lot of different dimensions all around the prism. But we're going to go ahead and dig a little bit deeper and take a look at it like this. So again, this says A here at the top, and that says B at the bottom. As long as you label it and as long as you keep yourself organized, that's the only thing that really matters, is how you keep your notes and your thoughts organized. So let's go ahead and take a look. So we have two rectangular prisms now. We have A and we have B. See this picture down here with the red one and the purple one? This is what I'm talking about as far as taking the one combined one and separating it. Because it's on paper, it's probably a little bit more difficult to do that. All right, so we have volume equals length times width times height. Now, this is where it gets a little bit tricky, and I wanted to really point out this. Take a look at the right here where we have 7 centimeters. That 7 centimeters represents that whole entire side. If we were looking at the whole entire prism as one big prism, yes, that would be 7 centimeters all the way. But because we partitioned it and we broke it down a little bit differently, we're not going to look at that side as 7. We're going to look at that side all the way up from the top, all the way up until it gets to that partition. So as soon as prism A stops and it gets into prism B, that's no longer part of the dimensions. So then how can we tell what that side's going to be? Let's go ahead and take a look at the opposite side here, where prism A goes down until it meets prism B. As you can see, this says 5 centimeters. So that side is going to be represented by 5 centimeters. So prism A is going to be 5 centimeters, 2 centimeters, and 4 centimeters. So right here, 4 times 2 times 5. It's a little dark, I'm sorry about that. So then we were able to multiply those together and get the volume for prism A, 40 cubic centimeters. And let's take a look at B. Same thing down here on the side. Instead of using that whole 7 that we looked at earlier, we're only going to use the portion that goes up to, starts from B and goes up to A. So on the side here, it starts from B, it goes up to A. But it's going to be a lot easier to see on the opposite side where there's nothing else that goes on top of it. And we see that that is going to be 2. So we have 2 centimeters is our height. And let's take a look at our other dimensions. We have 4 centimeters and 6 centimeters. So then we have 4 times 6 times 2. So for prism B, our volume is going to be 48 cubic centimeters. And then we put it back together. So we want to combine our volumes from prism A and prism B, and that gives us 88 cubic centimeters. All right, boys and girls, I have done a lot of talking, and I know you guys are eager to try this out. So in your package, you're going to have a couple of things that you can do. Right now, you have reteach page 10.4. Has some vocabulary at the top and a couple practice problems right there for you. And you could even do something on the back. And then we have the first practice page, which is going to be your guided practice. And that has a couple of examples at the front of it. And then you have independent practice at the bottom. And on the back, you have some more math practice and then problem solving. Go ahead and try these out. And as you're working through it, if you need more work, we have additional resources also. You have your center games, your extension, and if you have access and opportunity to, get on Dreambox and do some lessons on there. You have 6 to 8 lessons per week. So I know I had fun, and I hope that you did too. And until next time, stay safe and wash those hands.